Good afternoon, ladies and gentlemen, and I appreciate all of you accommodating me because I'm speaking in English, so thank you so much. As you can see, my name is Raj Singh. I'm the Solutions Lead from Hitachi Data Systems, and I'm going to talk to you about some of the solutions offerings we have that allow you to get more out of the data you collect on a day-to-day basis through your solutions and systems that you've implemented to date. So I'm sure everybody's heard of Hitachi as a company in one shape, way or form. As you can see, it's not a young company. It's been here over 100 years now. So we've certainly been providing solutions to the marketplace in all areas and aspects for quite a while. Oh, incidentally, I'll point out I'm not one of those 700 that has a PhD. So what people may not know about Hitachi is some of the areas that they play in. Like today I'm talking to you about our storage systems technology solutions, but also RFID technologies, biotechnologies, nanotechnologies, and so forth. So we bring a lot to bear. And looking at that, and what I wanted to point out here was if you look at sort of Hitachi's commitment to healthcare as a marketplace and an industry, although today I'm going to talk to you about solutions from Hitachi Data Systems, we have quite a rich presence within the market space. We have solutions from our sister companies like Hitachi Medical, so we know all about the capture of imaging at the point of creation. So that includes ultrasound, MRI, CT devices, and so on. We also provide a lot of testing and lab analysis equipment, as well as proton beam therapy for advanced cancer treatment and so on. So Hitachi is an interesting company that plays quite a significant part, certainly intrinsically within Japan. Culturally, Hitachi is very much linked to the government there with regards to a lot of the large-scale projects, not just for healthcare, but for other industries also. So let's quickly look at some of the challenges that face the industry. And certainly, clinical data growth is a very interesting one because it's just growing at absolutely phenomenal rates. If you look today, the amount of data being generated is doubling nearly every year. And that's easy to believe when you start looking at the size of PACS content, for example, or if you start looking at hospitals who are looking to fully digitize their pathology departments, that's going to generate large, vast volumes of data. But there's also a growing demand for access to all relevant patient data. In order for anybody to make the right or the best care decision, they need to be able to access content from multiple sources. You will find that a lot of hospitals will want to deploy solutions for their application sets based on best-of-breed choices on what they feel is most appropriate for them, which is fine, and it's the best way to go. But that in its own right throws up some of the challenges, which is they don't actually feel they have a patient-centric view of all of the content, and they don't have a single point of access. Often one of the common points that gets raised to me is, look, I'm a physician. I don't do IT, I do people. In order to help people, I need access to certain data. But if you're asking me to go and look in the lab area for the results, if you're asking me to go into different departmental systems to pull together the pieces of information I need in order to make the next decision, then that really isn't good enough today. And also you can't ignore this because there's regulatory impacts, and they vary country to country across Europe and certainly across the globe in general, which is about access to data, its retention, its deletion, its shredding. Can I delete it? Can I get rid of it? There's a lot of implications. And unlike any industry I've dealt with or seen before, when you hear of health insurance companies saying, we're legally obliged to keep data for 7 years, and you think, great. For healthcare patients, patient data can live for the lifetime of the patient and then maybe even 30 years beyond. And if it's a genetic disorder, you will never delete any of the content for any of that family, forever. So we really have to look at long-term retention of this content and access to it. But those challenges that it throws up is that with the choice of best-of-breed solutions is often access to that data is limited. You have to go through certain areas to get at it. Integration is difficult, and utilization of those assets can often be poor. So you may have underbought the storage you need for your PACS environment, or it's grows suddenly, or you've merged with another hospital and it needs to grow even more. So there's significant challenges. So there's no patient-centric view of the content, no easy way to get your hands on all of the information, plus all of those other challenges. The approach we've taken in Hitachi is quite unique. The first aspect of it was to remove some of those barriers to access to content. And the idea was to introduce storage virtualization as a technology that effectively changes the world you live in. It no longer matters who your storage solution is from, not even from Hitachi. You don't have to have Hitachi storage. The idea being that you take a solution whereby you classify the characteristics of the architecture you've deployed to deliver to you the information at the time and at the point that you want. It also means that complex IT tasks like migration, backing up, and so on become very simplified because you have a single view of all of your heterogeneous architecture across the whole hospital enterprise. It also allows you to integrate new solutions very easily because now it's a business-based decision. If pathology is suddenly going to go digital and they want petabytes of storage, you can thin provision that so you can give them maybe 500 terabytes with a policy that says when it's 80% full, automatically give them another 50 terabytes. You don't have to buy 5 petabytes today. But what this virtualization does, above all else, is for the very first time, it makes the placement of data application independent and is no longer reliant on the silos that were previously deployed. But then that's not all. The next challenge is your healthcare data grows and keeps on growing, and your production systems keep growing, and you need to deploy other capabilities, like the ability to archive. Most applications are quite clever in that they can do intelligent lifecycle management and will archive content. Drawback sometimes with traditional archiving is that archives is always seen as a very dark place where people think you hope to be able to get the data back, and often to access the data you have to ask all the application indices for what they filed away. So you're still stuck with asking at multiple points for that information. We've introduced a solution called the Hitachi Clinical Repository that uses our content platform. It gives you longevity in your medical records, retaining original content with its original file name, with policies to ensure that there's no duplication. If you're putting mammograms onto such a repository, they can be 1 gigabyte files. Well, if you add them up, they add up very quickly to being quite significant in size. It will deduplicate on the fly, and also apply all policies that are given to it on an object-by-object basis. So the idea is to try and introduce an interoperability framework for application-level neutrality to the content so that you don't have to keep asking at all the separate index points. And the way we've tried to address that, our vision is to put in place a repository that takes the feed from all of the applications and puts it into a single open store. And as it does so, there is a challenge here. While the X-ray is here in the production environment, the database knows all about it and the context in which that X-ray is referenced. When you put it into a repository, in its own right as a file, a DICOM image loses a lot of meaning. It doesn't mean anything to anybody unless perhaps a DICOM viewer. So we go to the trouble of capturing metadata regarding that object. What it is. In fact, we interrogate the DICOM header and take the entire contents of the DICOM header and write it out as an XML file associated with that object, so it now has meaningful use outside of the context of the application. This, for future, will enable independent search regardless of the source application that wrote that content in the first place. And we apply all the policies, object by object, as you require them, so that a physician can get a single access point to all of that content. And the repository can be accessed from anywhere. If you come over to the stand, you can see that the repository, the demo repository, is currently in London. But from here, through the internet, with the right permissions in the profile, you can get access to seeing and accessing the content relatively quickly as well. The whole view of all of this is to be able to give you the ability to have a single unified view of the patient, so that it doesn't matter where the content was generated, what type of device, independent of the supplier, anywhere in the hospital. But the one thing we had to be mindful of is that solutions come and solutions go. But the future demands a lot more. It says that the content must be available for very long periods of time. So we had to make sure that whatever we designed was almost independent of Hitachi. And to that aim, we made sure that when you write to it, the methods of ingest are API-free. They're based on industry standard protocols, HTTP, WebDAV, NFS, CIFS, however you want to write the content into the repository. And we also have to be mindful that it adheres to healthcare standards, so DICOM, HL7 messaging and so on, and IHE's XDS, XDSI profiles. The clinical repository has been taken to Vienna for Connectathon, and it was validated as a XDS repository layer. So it's already been thoroughly tested. The whole idea of the repository being to act as a central point to take multidisciplinary feeds from multiple applications anywhere within your healthcare enterprise and bring them together in a centralized access point where the method of access is through query, through any portal or application of your choice. All it has to do is issue its requirements for the information it wants, whether it's a PICS identifier based on IHE profiles, a unique patient identifier, or even a random search. Because the content stored is so granular, as is the metadata, you can do very clever things now. You can say to it, okay, go find me for all patients, for example, who are female between 40 and 43, who were given drug X and had adverse reaction Y. Now there's just a set of criteria for a search profile. So there is no limit to the search capabilities. It's just like Google. The more intelligent you search, the more intelligent the return of information. All with the view that it gives you an integrated electronic patient record, adheres to the XDS standards. It avoids the need for future migrations. The whole idea being is that it acts as an archive point for all the applications, but an open repository for access for the future, allowing application level independence. All with the view so that you can have a full clinical and non-clinical repository. I say non-clinical because hospitals don't just have clinical information. You also gather information from your standard IT systems. It will also store all of those. So all of your email archiving, for example, will also go into this platform. But that means now that if you have emails with reference points to patients, the system will find them in your search. Acts as a central store, and when we say performance and availability, because you can start this repository at a few terabytes, a single instance will scale up to about 40 petabytes. And if it's in the virtualized architecture I highlighted earlier, 247 petabytes. I don't think there's that much information in Norway yet, so there's plenty of scope to grow. It's based on standards. There's a web viewer which optionally you can put in. It's a multidisciplinary viewer and will show you content, whether it's a chest x-ray or an ECG or a nuclear medicine result or an ophthalmology result, whatever the information, and it will display those contents for you in multi-screens. All with one view to give you a highly scalable, application-level, neutral repository for the future, which allows you to turn your data into useful, meaningful information, and that, we hope, leads to better decision-making and hopefully improving patient outcomes. Right, that was very brief and quick, and the reason I wanted to keep it within time was because the full slide deck takes quite a while to go through, but my objective was to give you a bit of a flavor and an overview. If you require more information, please visit us on the stand. We've got some case studies as well that I wanted to share with you, and if you want to ask any more probing questions like how does it do all this, is it really open, etc., I'll be more than glad to answer any of your questions. Thank you very much.